Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. My topic for tonight will be a long video format topic, and the subject matter for tonight, we follow the trend that was recommended to us on YouTube. So I hope everybody watches this one because it was the recommended thing on YouTube. DC circuit in physics. So in here, the topic is DC circuit. DC circuit in physics is just a simple one. So I will be solving a problem, okay? Given this circuit in physics, it's just a simple one. Okay, so this will be the given circuit here. We got a DC circuit, assuming for the meantime that we are in the physics class. The resistances for the given circuit, to simplify calculations, I just place the resistance of all the resistances here to be 5 ohms. They are all 5 ohms. And they are connected to a single DC voltage source, which is a battery, and the voltage is 12 volts. And just to give emphasis on the concept of the study of DC circuit in physics, the problem is just asking for what will be capital letter R with the subscript T, meaning total resistance. This subscript T here refers to total resistance. And what will be capital letter I with the subscript T? Again, the subscript T refers to the total current. Okay, so this is just a simple one, and the circuit is a combination of series parallel. And this is series parallel. Without this resistance in the middle, the connection is just a pure series. But since I inserted this 5 ohms here, the given circuit is actually a series parallel combination. Because some of the components are actually in series, and those components are in the other components will be in parallel if we try to analyze it from right to left. Okay, like this one here. This 5 and 5 and 5 will be in series, and the single equivalent will be in parallel with this. That's why, like what I said, the given circuit is actually a series parallel combination. Okay, let's try to bring out the solution of this one. Okay, to compute for the total resistance, we must have to start it from the right. Then we'll go to the left gradually, meaning to say we will compress the resistances on the right. Then we try to remove gradually going to the left. Then till come a time that there will only be one resistance now left on the circuit. So, okay, let's try to start. If we try to analyze this 5 ohm here, this 5 ohm and this 5 ohm, I better use another color for this one. This 5 ohm here, I think my blue ink, no more ink. This 5 ohm here, and this 5 ohm, and this 5 ohm. If we try to circulate the current, okay, the current passing here, and so with this one, and so with the third one, will be the same. So we could say that this 5 ohm here, the second 5 ohm, and the third 5 ohm are all in series. So actually we could take the single equivalent of these three here now. And we will try to designate the single equivalent of the three to be RE with the subscript 1. Meaning equivalent resistance number 1. Okay? And this should be equal to. They are in series. If we try to analyze it, so the single equivalent of this 5 here, 3 pipes here, will be 15. So it will become 5 plus 5 plus 5. And this should be equal to 15 ohms. Okay? Then again, if we try to take the circuit upon the comparison of this 5 here, this 5 and this 5 to a single component, we could say that this single component here, which is RE1, which is equal to 15 ohm, okay, will be in parallel with this 5 ohm here. Why they are in parallel? Supposed to be this current here is different from this one, right? Since their current are different, we could say that this 15 ohm here, the single equivalent with this 3 here, will be in parallel with this 5 ohm. And we will designate the single equivalent of that to be RE2. And this should be equal to this 15 here, the single equivalent of this 3 is in parallel with this 5 ohm here. So if we try to take the single equivalent, okay, the concept is there are only 2 resistances in parallel. The concept is if we try to take the single equivalent, it will be the product all over the sum. So it will become, the first resistance will be 5, the second resistance will be 15, all over the sum, that is 5 plus 15. Okay? Product all over the sum. So if we try to simplify this one, 15 times 5, that will be 75, right? 75 over 20. And if we try to take the value of this one, we better take the decimal value now. 15 times 5 is 75, right? 75. So 75 divided by 20, it will become 3.75. 3.75 ohm. Okay? So the single equivalent of this 5 here plus the single equivalent of this 3 here, actually we place it here to be RE2, and this should be equal to 3.75 ohm. Okay? We'll continue the solution here. Don't worry guys, this is just physics. It's just a simple series parallel circuit. Okay, if we try again to analyze the circuit, this single equivalent, which is 3.75, will be in series with this 5 here and this 5. And I will be placing the single equivalent of that one to be RE with the subscript 3, and this should be equal to this 3.75 here, which is the compressed value of this, will be in series with this 5 and this 5. So it will become, since they are all in series now, it will be 5 plus 3.75 plus 5. Right? You see it, guys? This 5 ohm here will be in series with this. Okay? In series with this. So if we try to take the single equivalent, I designate that one as RE with the subscript 3. And what will be, this will be equal to 13.75 ohms. Okay? And if we try to analyze it, this 5 and this 3.75 in 5 is now compressed in just into a single resistor. So actually, we could rename that RE3 now. RE3 is actually equal to R total. And this should be equal to 13.75 ohms. So the total resistance now will be 13.75 ohms. Okay, you see it, guys? We start with this tree here. Upon compressing this tree, this tree here is in parallel with this 5 ohm, and we took the single equivalent of the parallel portion, and what comes out is 3.75, and this 3.75 will be in series with this, and so with this. So that's why, like what I said, RE3 will be 5 plus the single equivalent of this, which is 3.75 plus 5. And what comes out is 13.75. And if we try to analyze it, R total is actually RE3. That's why RE3 is actually equal to R total, and that will be equal to 13.75 ohms. So R total is 13.75 ohms. This is 13.75 ohms. Okay. Oh, what's next? The problem is asking for I total. Okay, we use Ohm's law. Voltage equal to IR. Right? So if we try to compute for current, it will be voltage over R. Right? And if we try to compute now for the total current, I will now try to place the subscript capital letter D here, meaning the total current of the circuit. It will be equal to, the total applied voltage is 12 volts all over 13.75. It's less than 1 ohm because the total resistance is 13.75. So 12 divided by 13.75, what comes out is 0.872. 0.872 amperes. So the total current drawn will be 0.872 amperes. Okay, that's it, guys. Okay, we are just given a simple series circuit, series parallel circuit. It's all 5 ohms. The problem is asking for R total and what will be I total. Like what I said, the total resistance is 13.75 ohms and the total current is 0.872 amperes. Oh, that is just a simple series parallel circuit. I could ask for some other requirement, but just to simplify or just to emphasize the concept of series parallel combination in Ohm's law, I just ask for the R total and the total current. And for the total resistance, like what I said, we will be starting from right, we are going to the left, and we try to compress the circuit. Okay, then till come a time that what will come out will just be single resistance. Okay, because after the compressing of the circuit, what comes out is just something like this. Okay, this is 12 volts, and the total resistance is 13.75 ohms. And if we are asked to find for the current, we can compute for the current. We are given the total applied voltage, the single equivalent resistance after the compression of all the resistances which are connected in series parallel combination, what comes out is 13.75. So if the total current is being asked, like what I said, I use Ohm's law, voltage equal to IR. Current will be the applied voltage divided by the total single equivalent. And what comes out is 0.872. Okay, that's it, guys. Oh, this is just a DC circuit. and physics. Okay, good evening from Los Angeles. This is Professor David J. De Los Reyes. The problem has just asked for the value of the total resistance and total current. Good evening from Los Angeles.